video explains cofferdams, the temporary watertight walls engineers build in rivers and harbors so they can construct in dry, open air. You've seen bridge piers standing in deep water, and the real question is simple. How did anyone pour concrete down there? The answer is that they didn't build underwater at all. They first pushed the water out, then built on the exposed riverbed. A cofferdam is a temporary enclosure that walls off a patch of the riverbed, letting crews pump it completely dry inside. Once it's dry, workers climb down and build bridge foundations, dam sections, or pipelines, standing on bare ground. The word gives it away. Coffer means a box or chest, and a cofferdam is basically a giant open-topped box in the water. Its only job is to hold water out temporarily, so it's built to be removed later, not to last forever. That single idea, keep the water out, work in the dry quaint, is behind almost every large structure with its feet in the water. But holding water back is far harder than it sounds, because water pushes on those walls with enormous, relentless force. This is hydrostatic pressure, and here's the key. The deeper you go, the harder the water pushes against the walls. At the bottom of a 10-meter cofferdam, every square meter of wall is fighting roughly 10 tons of water pressure. So the walls can't just be thin sheets standing in water. They need serious support, or the water crushes them inward. The most common cofferdam is built from steel sheet piles, long, corrugated steel sheets with interlocking edges that clip together. Each sheet slides into the one beside it through a groove called an interlock, forming a continuous, nearly watertight steel wall. A machine called a pile driver hammers or vibrates each sheet deep into the riverbed until it grips the soil below. Driven in a ring around the work zone, these sheets form a closed steel box, sealing off the water outside. But a tall steel wall alone would simply bend inward under the water's push, so engineers add internal bracing. Horizontal steel beams called walers run along the inside face, and struts brace across the gap, pushing the walls apart. Think of it like your hands pressing on both sides of a cardboard box, so the sides can't collapse inward. This frame of walers and struts turns 4 flimsy walls into one rigid structure, strong enough to resist the water. Now here's the detail most people miss. Sealing the 4 walls is only half the problem you actually face. Water doesn't just push sideways tight, it also seeps underneath the walls and pushes up through the soil at the bottom. Before fully draining a deep cofferdam, crews often pour a thick concrete slab across the entire floor first. This is poured underwater using a tremie, a long sealed pipe that delivers concrete straight to the bottom without washing away. The tremie pipe keeps fresh concrete separated from the water, so it settles into a solid plug instead of dissolving. That concrete plug seals the floor and, just as importantly, its weight resists the water trying to push up from below. Only now comes the satisfying part, dewatering, where powerful pumps suck out every bit of water trapped inside the box. As the water level drops, the riverbed appears, and a working site emerges in open air, surrounded by walls of water. But water never fully gives up, It constantly seeps through tiny gaps in the interlocks and under the walls. So the pumps rarely switch off. Keeping a cofferdam dry is a continuous battle that runs for the entire project. For groundwater on land sites, crews use well point systems, rings of small suction pipes that lower the water table around the pit. Cofferdams come in several forms, and the type chosen depends mostly on water depth, soil, and how much force is involved. The simplest is an earthen or embankment cofferdam, just a mound of soil and clay piled up to block shallow water. A single-wall sheet pile cofferdam is one ring of braced steel sheets, used for moderate depths and firmer ground. A double-wall cofferdam uses 2 parallel sheet pile walls tied together, with the gap filled with soil or rock for stability. That filled gap adds huge weight and strength, letting double-wall cofferdams safely hold back water up to around 12 meters deep. For the deepest, most exposed sites, engineers build cellular cofferdams, massive circular cells of sheet piling filled with compacted soil. Each cell is like a giant steel drum packed solid, and rows of them lock together into an enormous, self-supporting wall. Because they're filled and heavy, cellular cofferdams need no internal bracing. Their own mass holds them firmly against the water. When cofferdams fail, water usually wins from below, not from the side, through a dangerous process engineers call piping. Water forcing up through the soil can wash out fine particles, opening hidden channels that grow until the floor gives way. If the upward water pressure gets strong enough, the whole soil floor can heave up and boil, flooding the pit instantly. Other failures come from overtopping by a flood, buckling walls, or a single interlock splitting open under the constant pressure. That's why engineers obsess over seepage, add relief wells, and keep divers on hand to inspect the walls before dewatering. Cofferdams aren't new, Dodd. The basic idea is at least 2,000 years old, and the Romans mastered it for bridges. To build piers in a river, Romans drove rings of wooden piles into the bed and sealed the gaps with clay. They pumped the ring dry using bucket chains and screws, then poured their famous pozzolana concrete onto the exposed riverbed. The Sant'Angelo Bridge in Rome still stands on cofferdam foundations laid in the Tiber River more than 1,800 years ago. Some accounts trace the idea even earlier, to Persia around 539 BC, using earth banks to divert a river's flow. Modern cofferdams operate at a scale the Romans could never imagine, holding back some of the largest rivers on Earth. To build China's Three Gorges Dam, engineers walled off half the Yangtze with a colossal reinforced concrete cofferdam to work in the dry. That cofferdam was so massive and so strong that when the dam was finished, they couldn't simply take it apart. Instead, crews packed it with explosives and blew it up, using roughly 180 tons of dynamite in one carefully timed blast. The single demolition reduced the cofferdam to about 186,000 cubic meters of concrete rubble. People often confuse cofferdams with caissons, so here's the clean difference between the two in one line. A cofferdam is pumped dry so people work in open air. A caisson stays sunk and often becomes part of the permanent foundation. So the next time you see a pier standing in deep water, remember, there was once a dry box around it. Engineers didn't beat the water by going underwater. They simply built a wall, pushed the river back, and worked on dry land.